Good morning, friends. Welcome to my YouTube channel. Today I am covering capacity requirements planning. I already covered material requirements planning. If you have not watched that video, you can watch that video for understanding how MRP works. So let's start with the capacity requirements planning (CRP). Capacity requirements planning is a manufacturing and operations planning process used to determine whether an organization has enough production capacity, which is machines, labor, equipment, work centers, etc., to meet the planned production schedule. In simple terms, CRP answers the question: do we have enough resources and time available to produce what we have planned? It is usually performed after material requirements planning, which is MRP, while MRP determines what materials are needed and when. CRP determines whether sufficient production capacity exists to make those products on time. So this is the basic difference between MRP and CRP. Why capacity requirements planning is important? Without CRP, a company might accept more orders than it can produce, miss delivery deadlines, overload workers and machines, create production bottlenecks, increase overtime cost, keep customers waiting or unhappy. CRP helps management to balance workload and capacity, improve resource utilization, reduce production delays, make better hiring and equipment decisions, improve customer service levels. I hope it is clear till now. Key inputs of CRP. CRP uses information from several sources. First is Master Production Schedule (MPS), the production plan showing what products will be produced, quantity to be produced, production dates. Example: week product A. In week 1, 500 units of product A are produced. In week 2, 700 units of product A are produced. In week 3, 600 units of product A are produced. So MPS answered this question. Second one is Bill of Materials (BOM). It lists all components required to make the product. Example: one bicycle requires one frame, two wheels, one seat, one pedal pair, or more components. I just mentioned four components here. There can be several components of bicycle. Third one is routing information. It defines sequence of operations, work centers used, processing times. Example: operation, work center and time per unit. So for cutting operation, work center is machine A and time per unit is 2 minutes. For welding operation, work center is machine B, time per unit is 3 minutes. For operation painting, work center is machine C and time per unit is 1 minute. Fourth one is available capacity. It gives information about number of workers, machine hours available, working shifts, overtime possibilities. So these are the four inputs of CRP. First one is MPS, second one is Bill of Materials (BOM), third one is routing information, and fourth one is available capacity. Let's come to steps in capacity requirements planning. Step 1 is determine production requirements. Suppose demand is 1000 units of product X. This is our demand. Step 2, calculate load on each work center. Assume production process, work center and time per unit. For cutting, time per unit is 5 minutes. For assembly, time per unit is 10 minutes. For packaging, time per unit is 3 minutes. For 1000 units, cutting is 1000 into 5 because time per unit for cutting is 5. So 1000 multiplied by 5 is 5000 minutes or 83.3 hours. I converted the minutes to hours. For assembly, 10 minute is time per unit, and for 1000 units is 1000 into 10, which is equal to 10,000 minutes, and which is equal to 166.7 hours. For packaging, time per unit is 3 minutes, and for 1000 units, 1000 into 3, 3000 minutes, which is equal to 50 hours. So this is load on each work center. Step 3 is compare load with available capacity. Suppose available weekly capacity is for work center cutting capacity is 100 hours. For assembly it is 150 hours. For packaging it is 60 hours. So let's do the comparison between required and available. For cutting 83.3 hours is required, which I calculated here, and available is 100 hours. For assembly, required is 166.7 hours and available is 150 hours. For packaging, required is 50 hours and available is 60 hours. So assembly is overloaded by 166.7 minus 150, which is equal to 16.7 hours. Here cutting is required is 83.3, which is less than 100, so it is not overloaded, it is fine. Packaging 50 hours, which is less than 60 hours, it is fine. But in assembly, required capacity is more than available capacity, so which I calculated here, and which is 16.7 hours. So assembly is overloaded by 16.7 hours. Step 4 is take corrective actions. Possible solutions can be add overtime, hire temporary workers, add another shift, outsource work, reschedule production, uh, or buy additional equipment. These are the possible corrective actions. So let's come to real life example. Here I give an example of automobile manufacturing plant. Consider Toyota Motor Corporation producing 5,000 cars next month. The plant has three major departments: body shop, paint shop, and final assembly. So processing time per car department body shop is hours per car is 2 hours. For paint shop it is 1.5 hours per car. For final assembly it is 4 hours per car. So this is processing time. Calculate required capacity. Again, how many cars we have to produce? 5,000. So multiply 5,000 by these 2, 1.5 and 4 for the respective departments. So for body shop, 5,000 into 2 is 10,000 hours. For paint shop, 5,000 into 1.5 is 7,500 hours. For final assembly, 5,000 into 4 is 20,000 hours. So for body shop it is 10,000 hours, paint shop it is 7,500, and for final assembly it is 20,000 hours. Now available capacity for department body shop it is 12,000. For paint shop it is 8,000, and for final assembly it is 18,000. So these are the available hours and these are the calculated required capacity, and this is available capacity. Now capacity analysis, which I did earlier. Department is body shop, required is 10,000, available is 12,000. It is fine. For paint shop, required is 7,500, available is 8,000. It is also fine. For final assembly, required is 20,000 and available is 18,000. So it is overloaded. The final assembly department lacks 20,000 minus 18,000 equal to 2,000 hours. So this is a bottleneck. This final assembly is a bottleneck. Management may add overtime shifts, hire more assemblers, install additional assembly lines, outsource certain assembly activities, delay some production. So management can take a call out of these five options. CRP identifies this problem before production starts, allowing corrective action. So this is the major role of CRP. I hope it is clear till now. Common sequences: first sales forecast is done, then master production schedule, then material requirements planning, then it moves to capacity requirements planning, then production execution. What are the benefits of capacity requirements planning? It helps in better scheduling. Production schedules become realistic. It reduced bottlenecks. Problems are identified early before the production starts. It improved resource utilization. Machines and workers are used efficiently. It lower costs, less overtime and emergency outsourcing, better customer service. Orders are delivered on time. Improved decision making, supports expansion and investment planning. So these are the few benefits of capacity requirements planning. Let's come to limitations of CRP. Depends on accurate data. Incorrect processing time led to incorrect capacity plans. Assume stable conditions. Machine breakdowns and absenteeism can disrupt plan. Complex for large organizations. Thousands of products and work centers make calculation challenging. So these are the limitations of CRP, and these are the benefits. This is a common sequence. This is the step-by-step process for a real-life example, which I took here as Toyota Motor Corporation producing 500 cars next month. These are the four steps in CRP. These are four key inputs of CRP. CRP helps management, and without CRP, what company can face. And this is a basic definition of CRP and a simple comparison between MRP and CRP. I hope you understand capacity requirements planning in depth. If you have not subscribed to my channel, please subscribe my channel for more upcoming videos. Thank you for watching the video.